Today, we are going to discuss about the astronomical phenomena of solstice in detail, which might be familiar to the most of you. Hello students, we are back with a Concept Made Easy video where we are going to take up a concept and make it easy for you to learn. You might be having a rough idea about the most well-known astronomical event, the solstice. But today, in this session, we will learn what it means, what events are related to it, and how it influences the seasons on Earth. Equinoxes and solstices are what give rise to some phenomena on Earth because of the planet's inclination towards its axis. Seasons fluctuate on Earth as it circles the Sun. Solstice. A solstice is an event in which a planet's poles are most extremely inclined toward or away from the star it orbits. But before we discuss solstice, you must be aware of solar declination. Solar declination is the latitude of Earth where the Sun is directly above at noon, defines solstice on our planet. Or solar declination describes the latitude of Earth where the Sun is directly overhead at noon. The solar declination reaches the Tropic of Cancer in the north and the Tropic of Capricorn in the south at the solstices, which occurs twice a year on Earth. The solar declination of the June solstice, which is observed between June 20 and June 22nd, is around 23.5 degrees north, the Tropic of Cancer. Solar declination, which is around 23.5 degrees south, that is the Tropic of Capricorn during the December solstice, which is observed between December 20 and December 23rd. The Earth's 23.5 degree axial tilt as it circles the Sun causes solitons and varying solar declinations. This indicates that depending on which hemisphere is inclined towards the Sun during the year, it gets the Sun's rays at their strongest intensity. Despite having distinct dates in northern and southern hemispheres, the solstices are referred to as the summer solstice and winter solstice respectively. The longest day of the year is the summer solstice when the Sun is at its strongest and there are most hours of the daylight. The winter solstice has fewest daylight hours and is the shortest day of the year. The June solstice is the summer solstice in the northern hemisphere and the winter solstice in the southern hemisphere. The December solstice is the winter solstice in northern hemisphere and the summer solstice in the southern hemisphere. Solstices occur on every planet in our solar system. The planet's axial tilt, orbital eccentricity, and distance from the Sun all have a significant role in determining the date and size of the solstices. The axial tilt of Venus, the planet nearest to the Earth, is barely 3 degrees. Its solstices are spaced by around 3 months. Thus, Venus suffers relatively less seasonal fluctuations. Our other close neighbor Mars has a 24 degree axial tilt, which is identical to Earth's. Mars, on the other hand, orbits around the Sun in an orbit that is noticeably more elliptical than Earth's because of its substantially higher orbital eccentricity. Mars has dramatic seasonal fluctuations and its solstices are spaced around 11 months apart due to its greater orbital eccentricity and axial tilt. Signs of solstices. They are felt differently depending on the latitude of the Earth. They also mark the maximum point of dramatic exposure to daylight at the poles, while scarcely being recognized near the equator. First, let us discuss the equatorial regions. The equator at 0 latitude receives a maximum intensity of the Sun's rays all year. As a result, areas near the Earth's equator experience relatively constant sunlight and very little solstice variation. Now, let us see how it works in the mid-latitudes. Earth's solstices are largely marked by the transition of the subsolar point across the tropics. The latitude where the Sun's rays strike Earth perfectly perpendicular to the surface is known as the subsolar point. It is the location where the sun is above at midday. The subsolar point travels north and south over the tropics for the majority of the year before appearing at equator twice a year around the equinoxes. The subsolar point travels to its northern and southernmost latitudes at the solstices. On the June solstice, the Tropic of Cancer, which is 23.5 degrees north of the equator, receives direct sunlight. The subsolar point then starts moving south, and on the December solstice, vertical rays fall on the Tropic of Capricorn, which is 23.5 degrees south of the equator. Every latitude in between these two extremes will be traversed by the subsolar point twice annually. Lastly, let us discuss the polar regions. First of all, the Arctic and Antarctica are never reached by the subsolar point. The solstices represent when the sun is at its highest or lowest in the sky at the north and south poles respectively. Therefore, the solstices serve as the most extreme manifestations of the midnight sun and the polar night. The phenomena around the summer solstice, when the sun is still visible at midnight in the weeks preceding and after the event, is referred to as the midnight sun. Weeks preceding and after the winter solstice are referred to as the polar night, since the sun is below the horizon. And by that, we have come to a conclusion about the topic solstice and its phenomena. So that's it for today, guys. Hope you enjoyed the class, and we will be seeing you with new amazing explainer videos that will make your learning simple, easy and super fast.